Hello, 5th grade scholars. Today we will be engaging in Grade 5, Module 6, Lesson 11. Again, it's Mrs. Netler, and I'm super excited to continue our learning. Let's get going. Our learning goal for today is to analyze number patterns created from mixed operations. So we're going to continue our learning from the last few lessons, but this time, instead of having separate rules for just addition and multiplication, we're now going to explore the impact rules that have both operations will have when plotting points on a coordinate plane. Let's get going. The materials needed for today will be your Lesson 11 coordinate template and a straight edge. Once again, if you do not have your workbooks, that is fine. You can use grid paper or blank paper, whatever you have. Let's start with problem 1. We're going to compare the lines and patterns generated by mixed operation rules. Let's start with line L. What is the rule for line L? Right, we're going to triple x. So, what would be the y-coordinate if x is 2? Good. Y would be 6, because if I triple 2, I get 6. Now, before we graph line L, I would like you to make a prediction as to what you think line L would look like. So pause, make your prediction, and once you're ready, press play and we will keep going. Awesome thoughts. I would like to highlight a couple of predictions that I heard. I heard that it's a multiplication rule, so it will pass through the origin. That is something that we learned in the last couple of lessons. I also heard that the y-coordinates are 3 times the x-coordinates, so that it's going to be pretty steep. Alright, let's test our predictions. At this point in time, pause your video, find the remaining coordinate pairs for line L, and plot all of your points on the coordinate plane. Once you have completed that task, press play and we will come back together. Fantastic work. Let's complete my chart together. If my x is 0, what would be my y? Good, it would be 0. If my x is 1, what would be my y? 3. And if my x is 4, what would be my y? 12. Very nice. Now let's plot all of our points on the coordinate plane. So now that I have line L recorded on my coordinate plane, let's explore a new rule. Look at the rule for line M. The rule says triple x and then add 3. I would like you to think about this question. How is the rule for line M different from the other rules we've used to describe lines? I would like you to pause the video, think about that question, and when you have some ideas, press play and we will discuss. Wonderful thinking. So you notice that this rule has 2 operations. Previously, we have only worked with rules with 1 operation. So let's explore what we feel like the coordinate pair would be if our x is 2. So my first part of the rule says I need to triple x. So if I triple 2, what would I get? 6. Very good. The second part of my rule says add 3. So what is 6 plus 3? 9. Very nice. So my first coordinate pair that I found would be 2 and 9. At this point in time, I would like you to pause the video and find the remaining coordinate pairs. After you have found the coordinate pairs, plot the points on the coordinate plane. Once you have completed that task, press play and we will keep going. Fantastic work. Let's check my x coordinates in the chart. So I started with x being 0 times 3, and 3 more would be 3. Then 1 times 3 is 3, plus 3 more is 6. And then 3 times 3 is 9, and 3 more is 12. So let's go ahead and graph our coordinates. So I have 0 and 3, 1 and 6, 2 and 9, and I have 3 and 12. And then I'm going to create my line and label line M. Awesome work. At this point in time, I would like you to do a quick write. What do you notice about lines L and M? So pause your video, do your quick write, and once you have some ideas, jot it down, press play, and we will talk about it. Outstanding ideas. Let's review some of the key ideas that I heard. You notice that lines L and M are parallel. You also notice that the lines are almost identical, but line M doesn't pass through the origin. It passes through the y-axis at 0, 3. That is very interesting. The next question I have is, do lines L and M intersect? No, they don't, because you notice already that they were parallel. Now, I'd like you to do a quick think. What is different about the lines? So pause your video, come up with some ideas, and once you have some, press play and we will discuss. Rockstar thinking. Some of you notice that the points on line M are farther from the x-axis than the point on line L. You also notice that line M does not pass through the origin. So let's take a look at another mixed operation rule. Let's look at the rule for line N. Triple x and then subtract 2. So with line M, we had adding, and now we have subtracting. Let's do one together. Show me the coordinate pair for this rule when x is 1. So I would triple x and get 3, and then I would subtract 2, which would be 1. At this point in time, I would like you to pause the video and fill in the rest of the missing coordinate pairs. Do not plot your point just yet. So go ahead and complete the chart, and once you have that done, press play and we will keep exploring. Amazing job. Check your work with my work in the chart. At this point in time, I want you to think, based on the patterns that we've seen, predict what line N will look like. So pause the video, think of some predictions. When you have some ideas, press play. Fantastic. I heard a couple of things. One prediction was that this line would not go through the origin. I also heard that it's going to be parallel to lines L and M, and people thought that line N was going to fall below line L since we are subtracting. So let's go ahead and plot our points and let's see if our predictions are true. So I have 1 and 1, 2 and 4, 3 and 7, and I have 4 and 10. So I'm going to connect as best as I can and label line N. Fantastic. All right, now that we have line L, M, and N on our coordinate plane, I would like you to do a quick think. What have lines L, M, and N taught you about lines generated from mixed operations? So I want you to pause the video. I want you to think about a couple of ideas. Once you have some, press play and we will discuss. Outstanding thinking. I would like to highlight a couple of ideas that I heard. The first one is that you can actually generate parallel lines involving multiplication, but you would have to add or subtract after multiplying. I also heard that not every rule with multiplication will produce a line that passes through the origin. So when you add that adding and subtracting, it no longer passes through there. I also heard that if the multiplication part of the rule is the same for both lines, adding after multiplying makes the points on the line shift up by whatever you're adding. And then in the other way, subtracting makes the points on the line shift down if it's part of the rule. So awesome thinking. Let's go ahead and keep digging a little deeper. Moving into problem 2, we're going to identify coordinate pairs to satisfy mixed operation rules. So I have a rule written here. Multiply x by 1/2 and then add 3/4. I would like you to do a quick think. What would the line described look like? So pause the video, do your quick think, and once you have some ideas, press play and we will keep rocking. Amazing ideas. I would like to highlight a couple. So some people notice that it's a mixed operation, so it will not go through the origin. Also, the rule has you multiply by 1/2 first. Multiplying by 1/2 will be a line that is less steep than multiplying by a whole number. Interesting. So let's go ahead and explore what this rule would look like. So let's do the first one together. If I have my x as being 1, I need to figure out what would be my y coordinate. So following the rule, I would begin by multiplying 1 by 1/2. I know that 1 times 1/2 would then be 1/2. Then it says add 3/4. So I would add 1/2 and 3/4. If I can make a connection back to Module 3, I know that I need to have like units in order to add fractions. So I would need to make 1/2 into an equivalent fraction with fourths. Well, knowing that 1/2 is 2/4, I could change that to 2/4 and then add 3/4. So I have 2/4 plus 3/4, which is equal to 5/4. I also know that 5/4 is a fraction greater than 1. So if I wanted to put that into simplest terms, I could make that 1 and 1/4. So the coordinate pair for y would be 1 and 1/4. Awesome job. I would like you to try 1 and 1/2 on your own. So pause your video, try to find the y coordinate when x is 1 and 1/2. Once you have finished that, press play and we will keep going. Great. Let's check our work together. So I'm going to start with 1 and 1/2 times 1/2. Now I use the distributive property that I learned in Module 4. So what I'm going to do is I'm going to multiply 1 by 1/2 and then multiply 1/2 times 1/2. So I know 1 times 1/2 is 1/2 and 1/2 times 1/2 is 1/4. So again, I need like units to add. I just found out that 1/2 is the same as 2/4. So 2/4 plus 1/4 equals 3/4. So that's the first half of the rule. I still need to add 3/4. So I would do 3/4 plus 3/4, which would give me 6/4. I do notice that 6/4 is a fraction greater than 1. So putting it in simplest terms, that would be 1 and 2/4. I could also rename that as 1 1/2. So my coordinate pair would be 1 1/2 and 1 1/2. Fantastic work. Let's keep going. All right, I would like you to do a quick think. Would the line for this rule contain the point 3 and 2 and 1/4? So I'd like you to pause the video, do your quick think, and when you have your answer, press play and we will keep going. Awesome thinking. I noticed that you said it would contain that point. And if that's because 3 times 1/2 is 3/2, and 3/2 plus 3/4 is equal to 9/4, which would then be 2 1/4. Great job. At this point in time, I would like you to generate another coordinate pair that the line for the rule multiply x by 1/2 and then add 3/4 would contain. I did give you an example. I would like you to explore a different coordinate pair, but I want you to use the same process that we used to discover your own coordinate pair. So go ahead and pause your video, find your coordinate pair. Once you have that, press play and we will keep going. Great job. There were a number of different ways that you could come up with your two coordinate pairs, but I would like to reiterate the fact that when we have mixed operations and we have multiplication mixed with adding or subtracting, the rule no longer stays that they pass through the origin. Also, you can create parallel lines with multiplication, but you would need to add or subtract in there as well. Let's keep going. It is problem set time. For this problem set, I would like you to do number 1 and number 3. So again, this is grade 5, module 6, lesson 11 problem set. If you do not have your workbook, these are the two problems on your screen, so you could solve them on blank paper, but give yourself at least 10 minutes to work through those two problems. Once you have finished, press play and we will review. All right, let's go over number 1 together. So for letter A, we are going to draw each line on the coordinate plane above. So let's start with line L. The rule states that it is double x. So this is only one operation. We're only multiplying by 2. So 0 times 2 is 0. 1 times 2 is 2. 2 times 2 is 4. And 3 times 2 is 6. So we only have multiplication, so this will start at our origin. And let's plot the rest of the points. And this is line L. Very nice. Now we move into line M. The rule for line M now says double x and then add 1. So 0 times 2 is 0 plus 1 is 1. 1 times 2 is 2 plus 1 is 3. 2 times 2 is 4 plus 1 is 5. And 3 times 2 is 6 plus 1 is 7. So notice that we had 2 operations, and now my line will not start at the origin. So I start at 0, 1, 1, 3, 2, 5, and 3, 7. And I will label. Good. Now it says to compare and contrast these lines. So let's do some comparisons. What do they have in common? Well, they're parallel. Also, they appear to be at the same steepness. They also have in common that they're doubling x. But what's different about them is that line L starts at the origin, but M does not. As well as M, you are adding 1 to your x, which is causing that to be further up on your y-axis. And the last part says, based on the patterns you see, predict what the line for the rule double x and then subtract 1 would be. So we have seen that before. When you subtract x, or subtract from x, we would then fall below line L. We would be closer to the x-axis. So if we could make a prediction, if we're subtracting 1, then we could say that the line would probably fall around there. Okay, if you guys have any questions, you could always ask your teacher. But congratulations, you've completed the grade 5, module 6, lesson 11, concept development. Make sure you upload your work and go to Zearn to continue your learning. Again, I am super proud of how hard you are working, and I can't wait to see you on the next lesson.